All right, this exam will finish explaining the questions on sample exam number 3. Okay, determine the equation of the tangent line to this graph at this point. So for the tangent line, we need a point, which they're giving us, and we need the slope, which comes from the first derivative, right? The first derivative at the point. So let's take this and take the first derivative. Okay, we will end up using the chain rule right here, won't we? So the derivative of sine is cosine of x squared. Yep, the derivative of the inside is 2x plus 0 because the derivative of 1 is 0. All right. At this point, and I'm not sure how you're supposed to know unless you can use your calculator, but I'm going to say the slope is the cosine of the square root of pi over 2 squared times 2 times the square root of pi over 2. Well, the square root of pi over 2 squared, right, would be the cosine of pi over 2 times 2 times this radical. Well, the cosine, if I draw myself a graph, does this over the course of 2 pi. That's pi. Pi over 2, the cosine is 0. Okay? Which makes the slope 0 times this thing, which is 0. Alright, so the slope is 0, telling us this is a horizontal line. And the equation for a horizontal line typically is y equals some constant. Well, if it's at this point, you use the y, right? Y equals 2. And if that didn't make sense to you, you could do something like, whatever this is, you could graph the x and then the y of 2. All right, and if it's horizontal, it runs through that. Okay, y equals 2. All right, so again, we were given a point and the slope. Let's try it, just let's say the slope was 1. If for some reason we had a slope of 1, just to refresh our memory on how to find the equation of a line, y equals mx plus b. We have an x and a y, don't we? But we don't have a b. We have a slope, we're just saying, of 1. This is hypothetical, right? So y equals 1 times x, whoops, plus b. So if I subtract this over, on both sides I get 2 minus equals b, right? We can calculate that, or we can leave it as an exact number. But that's our b. So my equation would be y equals the slope times x plus b. In this case, it's a little more complicated than normal. All right. Let's look at this. Number 5. Find the derivative of, I'll just do y, 2 plus x to the 4th to the 2/3. So we have a chain rule, right? The outside is a power rule, and then we'll do the inside, which is the chain. So the derivative equals, this comes down in front, 2/3, 2 plus x to the 4th, 2/3 minus 1 should be a negative 1/3, right? Times the derivative of the inside. Well, the derivative of 2 is 0, and then we use the power rule here, times 4x to the 3rd. If we don't simplify, that's all we have to do. Right? Whoops. 6 uses implicit differentiation again, right? Which is a little more complicated. It's going to take a few more lines. So, remember, for implicit differentiation, anytime we're taking the derivative of a y, we're adding dy dx there. So, first, this will be 6x plus, now we got to use a product rule, don't we? The derivative of the first, 2x times the second, plus the first times the derivative of the second. Well, the derivative of y is 1, dy dx. Man, we have to use the product rule twice here, don't we? Okay. Now, product rule on this piece. Derivative of x is 1, y squared plus x times the derivative of this, which is 2y dy dx, equals 0, right? The derivative of a constant is 0. So we have two terms that have a dy dx in them, three terms that do not. So I'm going to put the three terms. I have 6x plus 2xy plus y squared. And on the other side now, when I subtract those both over, I'll have minus x squared dy dx minus 2xy dy dx. I just reordered this thing here. Factor out dy dx. And I have, oops, I don't mean that. Factor it out, not of this, and I'll have negative x squared minus 2y. So I'll divide both by this. So my final dy dx looks like this, doesn't it? These are ones where you need a lot of room. You don't want to lose signs. You want to just take your time, okay? All right. At what points on this ellipse is the tangent at the point, tangent line at the point, parallel to this line? Well, this line, right, according to y equals mx plus b, has a slope of negative 2, right? So we're going to try to find out where our slope is negative 2 on this line. So I have to take the first derivative, don't I? Implicit. So this will be, whoops, try that again. The derivative is 6x plus 2y dy dx equals 0. Let's solve for dy dx and move it. Now I'll divide this on both sides. So dy dx is 6x over negative 2y. That negative can go anywhere, can't it? Now we want to know when this derivative, all right, I can actually simplify this too, can't I? So it's, I'll just put the negative here, 3x over y. When is this equal to negative 2? Well, I have to go back to my original equation to get the relationship between x and y, don't I? So I come up here and I say, well, what's my relationship between x and y on this ellipse? Well, I'll subtract this over. So y squared equals 21 minus 3x squared. Then the square root of y is this. So y squared. So this y is equal to plus or minus of this value. Come over. So first, I'll use the positive y. So negative 3x over y, right? Plus or minus, oops, I wanted to use the positive first. Positive 21 minus 3x squared equals negative 2. Now let's solve for x. I'm going to cross multiply. Negative 3x equals negative 2 times this radical, right? Divide by negative 2. So 3/2 x equals this radical. Now when you get rid of this radical, don't we square both sides? So now we have 9 over 4x equals, a radical squared just gives you that inside, doesn't it? Oops, I forgot to square this. We got a square there, don't we? Alright, so if I add 3x squared to both sides, 3, let's not forget, 3 over 1 is equal to 12 over 4. So 12 over 4 plus 9 over 4 was 21 over 4x squared equals 21. Interesting. Now solve for x squared. I'm going to multiply by this reciprocal. I need to get rid of that. X squared equals 4. Interestingly enough, x equals plus or minus 2. So at, what we've just learned is that y equals this positive point, We have to go back and figure that out in a minute. If y equals a positive point, I have x equal to plus or minus 2. Okay? Now we're going to try the negative. I should have left myself more room. So, if I try the negative, notice something. Well, negative 3x over the negative of this. I'm just going to leave the radical equals negative 2, 1. We'll cross multiply. Negative 3x equals negative 2. Well, these will go away, won't they? Let me leave them. Let me leave them. But negative 2 times the negative radical is the positive 2 radical, isn't it? Divide by 2, divide by 2. Now we square. Notice when we square this, that negative will go away. So when we have the negative radical, we are going to get the same answer because this thing squared is 9 over 4x squared equals 21 minus 3x squared, which is what we had right here. So that was when y is positive. When y is negative, that negative radical, guess what? We get the same thing, don't we? Now, when we plug in plus or minus 2, because here, right, here's what we have, y in terms of x. We have to plug in some x's. If I plug in, notice this is squared too, so it doesn't matter what sign I plug in. So y will be plus or minus 21 minus 3. 2 times 2 is 4. 21 minus 12, y equals positive and negative square root of 9, positive and negative 3. This is what we have. We have the positive 3 and the negative 3. So finally, if I write the points where the tangent line is parallel to that, I have 3, 2, 3, negative 2, negative 3, 2, negative 3, negative 2. I'm going to come back to that one, so I want to double check it. All right, they're giving us all sorts of good stuff here. So A, when it is written like this, it's saying add together f prime of 2 plus g prime of 2. Well, they give us f prime of 2 is square root of 2. G prime of 2 is 1/2. So that's the answer to A. B is a quotient rule, isn't it? So let's take that, and it becomes f prime of g times g of 3 minus g prime of 3 times f of 3 all over g of 3 squared. Alright, f prime of 3 is 2. G prime of 3 is 1/2 minus, oops, I need g of 3, my bad. G of 3 is 1. G prime of 3 is 1/2. F of 3 is negative 1 all over g of 3 squared over 1. So this will be 2 times 1 minus plus 1/2 equals 2.5. Now, composition, right? So what we have here, let's take h prime. Let's first of all, h equals f g of x squared, right? So h prime, first it's f prime of this thing, right? Times the derivative of the inside, we're going to use the power rule to 2 g of x times g of x prime. Alright? So we would go ahead and plug those in. And we're finding it at 2. So g of 2 is square root of 3 squared is 3. So this is f of 3 times 2 times g of 3 square root of 3 I'm not going to finish this.